All right, welcome to section 3. This will be quite a long section, so I do apologize for that. But that's one of the reasons why I decided not to do this on Friday. And what we're going to talk about is the arc length of a curve and the curvature of the curve, and also different types of vectors. So we talked about the tangent vector. We're also going to talk about the binormal vector and the normal vector. But first, we're going to start with arc length. And so here we have defined the length of a plane curve with parametric equations. X is equal to f of t, y is equal to g of t, a is less than or equal to t is less than or equal to b. So our t is in between two values a and b for the case where f prime and g prime are continuous. So closer towards the end of calculus 2, you were able to find the length or the distance of a curve given two parametric equations, and that's basically what we're doing here. But instead of just doing with two parametric equations, now we're extending that to three-dimensional. So we're finding the length of a curve in three-dimensional space. All right, and it's very similar to what you learned last year in Calc BC. It's the same formula. This is just for two parametric equations and define the length of a curve given three parametric equations. It's just the same. We're just extending it and adding in that third component. All right. And so here's just basically the formula. It's the length is equal to the integral of the pretty much the magnitude of what our vector is, all right, the magnitude of the derivative of our vector, all right. And so what we have done is, instead of having to write it all out this way, you have to shorthand it to write it in a more compact way. All we're doing is we're finding the length is equal to the integral from a to b is equal to the magnitude of r prime of t dt. So let's go ahead. Now you might want to say, why? It's just because we know what the magnitude of r prime of t is. If I'm asking you to find the magnitude of r prime of t, then what that is, it's just the square root of our x component squared plus the derivative of our y component squared plus the derivative of our z component squared. All right, and so that's why we can just write it shorthand. So I mean, the y here, hopefully you know what the magnitude is of the derivative of our vector equation. All right, so example 1, all we're going to do is we're just going to find the length of our curve r of t, which is equal to 2t, t squared, and 1/3 t cubed. All right, so here we're given a vector, and the first thing we want to do is let's go ahead and find the derivative of our vector. And so the derivative of our vector is going to be, derivative of 2t is just 2, derivative of t squared is 2t, and derivative of 1/3 t cubed is just going to be t squared. All right, and then now that we've taken the derivative, let's go ahead and find the length of our curve from 0 to 1, and again, we're just finding the magnitude of our derivative of our vector. And so now, let's go ahead and rewrite this as 0 from 0 to 1, the integral from 0 to 1, square root of our vector, which is just going to be 2 squared plus 2t, quantity squared, plus t squared dt. And again, let's rewrite this as the integral from 0 to 1. And let's go ahead and combine what we can. So 2 squared is 4, plus 2t squared is going to be plus 4t squared, and t squared squared is just plus t to the 4th dt. Then hopefully you know this from algebra, is that we can actually factor 4 plus 4t squared plus t to the 4th. To factor that, we would just get 2 plus t squared dt. And the nice thing about that is the square and the square root are going to cancel each other out, so we're now just left with the integral from 0 to 1, 2 plus t squared. Let me write that a little bit better. T squared dt. Now let's take the integral. The integral of 2 is going to be 2t. The integral of t squared is going to be 1/3 t to the third, going from 1 to 0. Substitute in the 1 and get 2 times 1 is 2, plus 1/3 times 1 to the third power is just going to be 1/3. Minus, plug in 0 for t. Both t's is going to just give us 0. So 2 plus a third is going to give us 7/3. And so there's the length of our curve.